Hello, so this is the Nikon microscope. So it's used for general analysis of our samples. So if I have just done a patterning of my sample here, then I'm just going to put the sample on this rotating holder. Then I normally put it as close to the center of the holder as I can. And then I use these two knobs that I find on the right hand side, one to control the movement on the y-axis and one to control the movement on the x-axis until I place the sample under the light of the lens. There is a filter, depending on the kind of sample that I am using. I might have to examine samples with photoresist, so it's useful to apply a filter to the light, and I can do these through this handle on the side, because if the handle is pushed all the way in, then there is a yellow filter applied to the light, which is what is normally used for the examination of substrates where photolithography is used. If I pull it out, then the yellow filter is removed and I can see that the light is not yellow anymore, it's actually white light. So I need to be careful if I'm examining samples with photoresist, especially to make sure that the yellow filter is applied so that I'm not exposing inadvertently the photoresist. Then once my sample is under the lens, I need to bring the sample in focus. So there are two knobs on the right hand side. One is for the coarse control of the focus, and the other one is for the fine control of the focus. So this microscope has actually several objectives that can be used. It has 5, and one has to be careful because these 5 objectives are actually short working distance objectives. So there's a possibility that if I'm not careful, the lens might hit my sample. So I always want to make sure that I start from the lowest magnification objective, which is also going to be the farthest away from my sample. So I want to start from the 5 magnification one, and afterwards, once my sample is in focus, I can actually use these keys right here on the bottom to actually switch between the different objectives. And the biggest magnification one is actually 150 magnifications. So there's 5, 20, 50, 100 and 150. Normally one always starts from the 5 magnification objective. And then after making sure that the lens is the lowest magnification and that the distance from the holder is actually big enough so that my sample won't crash into the lens, I can actually move my sample underneath the light, and then I can start bringing my sample into focus. In order to do this, I can use these two knobs here. The outer knob, the one that I'm indicating right now, is the coarse focus control, while the smaller knob, this one here, is the fine focus control. So once my sample is into focus, then there are a number of features that can be used in this microscope. For example, if I have to submit this sample for electron beam lithography, one useful feature is that I can measure distances and coordinates with these. So if I by pressing these two buttons, X0 and Y0, the second and third button from the left on this module here, that coordinate will become the origin of my coordinate system. And and normally that's what one does to measure the cross when submitting for electron beam lithography. So I aligned my sample to the lower left corner, then I press 0 and 0, and then I go to the cross, and then I note down the cross coordinates for the submission or with the electron beam, for submission for electron beam lithography on the JWNC website. Another thing that I can do with this microscope is taking pictures of the features that I'm examining. In order to do this, there's a CCD camera that is plugged in on top of the microscope, which is connected to the PC that is on the left hand side of the microscope. In order to see the image that is captured by the CCD, I need to double click on this progress capture pro icon, and this will immediately start the software, and here I can see my image. Okay, so the focus is actually slightly different from the viewer to the camera. So when I'm focused on the viewer, the image actually appears blurred on the CCD camera, and so if I want to take an image, to capture an image, I actually need to make sure the focus is so that the image appears sharp on this display. Then if I want to, I can change the color, I can change the brightness, I can change the contrast, I can change the saturation if I'm not happy with the default settings. I can change the exposure time. There's a number of other tools that I can use, and once I'm happy about the image that I want to take, I just press capture, and then will stop the CCD camera from taking live images. And so now, even if I move the sample outside of the field of view of the objective, you see that the image is still there. And in this case, the image was also already saved, because under the settings tab here on the left hand side, I can select the file option. So I can select the target folder on this computer where to save the images, and I can actually select the name that those images will have. This is of course only if the autosave option is selected. Otherwise, so once I captured and I saved my image, I can actually unload the sample from the microscope, so I can bring it out of the field of view of the lens, and then I can retrieve it with my tweezers and put it in the sample box. And one thing that I want to make sure I do, I want to make sure that I close the software here, and I also bring down the intensity of the lamp to 0, and I switch off the generator. That way, when no one is using the microscope, the light bulb is not heated, and that will make the lifetime of the light in the microscope longer, and it will require less maintenance.